Now take a look at this volcano over here. Usually when you see a volcano, right, the lava that comes out is kind of this orangish kind of color, or orangish red kind of color. That tells us that it's really, really hot. The temperature is very, very high. And then as it flows down over here, slowly it starts to cool and it darkens. And it turns back into dark colored rock. So why is that the case? Why is it the case that when the lava is really hot, it's kind of this, yellow or red, bright color, and it produces this light? And then when it cools down, well, it darkens. Well, you notice the same kind of thing when someone is using the stove. So where's this picture over here on the right? This right over here is the coil on a stove in the kitchen. So probably most of you have, stoves that look like this, right? So normally the stove, when it's turned off, is just kind of like a black or dark gray kind of color, right? That's when it's turned off. But what happens when you turn the stove on? Well, all of a sudden, this coil starts to heat up and become hotter and hotter. And it becomes so hot that it can even cause water to boil, right? And what do you notice when you turn the stove off, when you turn the stove on, when your parents turn the stove on? These coils start to brighten and produce light. They usually produce a red or orange kind of light. So whenever things become hotter and hotter, many substances, they change color and they start to produce their own light. So that's exactly what's going on over here. When this rock is at a very high temperature, just like these coils, it starts to produce its own light. When it cools back down, just like the coil, then it darkens again and it stops being bright. So this over here is a bunch of lava that has cooled down. So when the lava came out of the volcano, it was obviously very bright because it was really hot. But now over a long period of time, it has cooled down, and now it's no longer molten rock. It's just solid rock. So now it just turned back into kind of this dark gray kind of color. All right, let's take a look at different kinds of lava. All right, let's start with this picture over here on the right. All right, so what are we seeing over here on the right? Well, we're seeing 3 different kinds of liquids. Over here we have water. All right, so someone turned on the faucet and some water is flowing out of it. Over here we have some olive oil. All right, so maybe your parents, they buy olive oil or vegetable oil or something like that. And again, this is also kind of a liquid, right? You can pour it out, right? Over here we have honey, right? So honey, someone is trying to pour out the honey, right? So what's kind of the difference between these different substances? Well, this honey over here, let's suppose you try to pour it out, all right? Which of these liquids would you be able to pour out the fastest? Obviously, it would be the water, right? If you turn on the water, this water is going to rush out really, really quickly. But let's suppose you take like a jar of honey and you try to pour it out, right? What's going to happen? Is it going to pour out just the same as the water pours out? Of course not, right? The honey is going to be really thick. It's going to flow very, very slowly, all right? The water is going to flow quickly. The honey is going to flow very, very slowly. So lava also comes in different forms. Just like these liquids come in different forms, lava also comes in different forms. Some lava behaves like water. All right? Some lava behaves like water. It's really, it flows out really, really quickly. And as you can see in this picture, it can just, flow away from the volcano very, very quickly. It just flows away very quickly. And so some volcanoes, when they form, they don't form very tall volcanoes. Take a look at this volcano. Does this look like a tall volcano? No, this volcano is almost, is very flat because the lava that came out of here is almost like water. And so, that water just kind of flows away very quickly. And so this volcano cannot form a very tall volcano. But take a look at this volcano down here. This volcano down here, its lava is more like honey. So when this lava flows out, it just kind of quickly bunches up and starts piling on top of each other, just like honey piles on top of each other. And so this volcano can form a very tall volcano. So this behavior of different kinds of liquids, this is called viscosity. Right? Take a look at this word up here, viscosity. You would say that water has very low viscosity, right? Has very low viscosity. Olive oil is kind of like in the middle, right? So it has medium viscosity. And then those liquids that are the thickest, they have very high viscosity. Again, this one over here is showing you what happens to volcanoes when they have different levels of viscosity. So over here is the chart for viscosity, right? So over here is less viscosity, right? Or low viscosity, kind of like water. So this lava up here is just going to be kind of like water. You can see just kind of flowing away very quickly. So you can't form like a very tall volcano here, because before the lava can start to accumulate and bunch up and form a tall volcano, it just flows away quickly. This one over here is kind of like in the middle. And then this one over here you can think of is, has very high viscosity, just like honey. So over here when the lava comes out, it starts to bunch up very quickly. It can quickly form a very tall volcano. All right. So this picture over here on the left, this picture over here all the way on the left, all right, what does it show? So this is showing us a volcano on top of the land, and it's showing us where that lava is coming from. So the lava comes from a magma chamber all the way here down at the bottom. All right. So what is magma? Magma is molten rock. All right. So the earth is filled with rocks, right? But this rock over here has melted. The temperature inside the earth is so high over here that the rocks actually melted. And so what happens? These molten rocks, these start to try to go all over the place, right? Some of them, they can rise all the way here and form a volcano and come out of the earth, right? But in a lot of places, the molten rock, right, it can't get to the surface. It just starts to try to creep its way, sideways over here. It starts to go up and it stops here. So it goes in all different directions. The lava doesn't just, reach the surface, or the magma doesn't just reach the surface to become lava. It tries to go in all different directions. So sometimes it reaches the surface and turns into a volcano, but sometimes it just starts to, melt its way through the other rock over here, and eventually it cools down and forms rocks over there. So whenever you have molten rock that forms magma underneath the earth, some of it goes out and forms a volcano, but the rest of it kind of just stays down here and tries to go in all different directions. All right. So this picture over here is showing us that when a volcano erupts, all kinds of different types of things come out of it. Sometimes there's lava, sometimes there's broken rock, sometimes there's all kinds of gases that come out of the volcano. Right? So the rocks are going to kind of fall down the sides of the volcanoes, but the gas is going to erupt and go off into the sky. This is showing us different types of volcanic eruptions, right? So this one over here on the right is from Indonesia in 2006. So you can see that some of this stuff, some of this heavy stuff is going to fall down the side of the mountain, right? That's called pyroclastic flow, right? The heavy stuff is going to fall down the side of the mountain. But the gases, those are very light. They can just go off into the air like this, right? So different kinds of things come out of the volcano. It's not just lava. All kinds of different things come out of the volcano. Take a look at this volcano over here, right? This is a volcano in Alaska, right? So do you notice like a lot of pyroclastic flow going down the volcano? Do you see a lot of rocks, like a lot of heavy rocks that are tumbling down the side of the volcano? Not really, right? Over here, you just see mostly gases. Mostly gases. So these gases are going to just go up into the air and float off into the air. Right? So it says here, a volcano in Alaska erupting large quantities of steam. So there's not much lava coming out of here. Mostly is just steam. Right? So take a look at this picture over here on the right. All right. What does this picture have to do with a volcano? So what happens when you take, a can of soda or a bottle of soda? Well, what happens is that when you open the soda, all right, you notice that suddenly all kinds of bubbles start to come out of the soda, right? All of that gas, right, used to be packed inside of the soda. It was under a lot of pressure, right? At the factory where they make the soda, they took a lot of this carbon dioxide gas and they pumped it deep into the soda and closed the soda can under a lot of pressure. So all of that gas couldn't escape. But suddenly open it and all of that gas suddenly rushes out and forms bubbles. That's basically how a volcano works as well. All of this gas used to be trapped underneath the earth under a lot of pressure. But suddenly something over here broke. Maybe some rocks cracked open or something happened. And all of a sudden, just like opening a soda can, all of that gas starts to rush out of the volcano and goes off into the sky. This picture over here shows some frozen lava. So what do you notice? This lava, this rock that came from lava is filled with all kinds of tiny holes. So why are there holes in this rock? Well, the reason is because when this lava erupted, it was filled with gases that were coming out of the volcano. And so when this rock, cooled down and turned, back into solid rock, it's filled with tiny, tiny holes.